for topic 5 ni, this is the last one. We learn about power. So power ni ada dua formula. As you can see here, we have P is equal to W over T. This one is the formula that you have learned or used before during secondary school. Alright, masa sekolah menengah dulu, your teacher must have used this formula to calculate power. And this is going to be the other formula to calculate power, which is force multiplied with velocity. Okay, so simply put, you can read the notes here, tapi kita guna different analogy instead of using cars. As using cars as in the notes. Sebab dekat dalam notes ni, they talk about power of a car. Alright, so we have two cars, different cars. And we can imagine, let's say, kita guna simpler analogy. So imagine your calculus or mathematics lecturer. Can I know who's your mathematics lecturer?
Sir Takiuddin.
Sir Takiuddin. Seronok tak belajar dengan dia?
Seronok.
Seronok kelas malam kan?
Yes.
8.10 Okay, so because I heard Sir Taki prefers to do class at night. Okay, so let's say Sir Taki bagi kerja. What kind of kerja? Kerja tu adalah work lah. Work. Okay. Ataupun kita boleh panggil dia sebagai, the work tu kita panggil sebagai, sebab when we talk about mathematics, mestilah banyak home work. Alright, so it's normal. Mathematics requires you to do a lot of questions or example over and over again. So there's a lot of homework. Tapi Sir Takiuddin or any of your calculus or mathematics lecturer will definitely give the same amount of work. Tak adalah tiba-tiba Nurizuddin dapat kerja yang lebih banyak berbanding Syazan ke. It's the same homework, the same amount of homework. So we can imagine that sesiapa yang siapkan homework tu with lesser time, we can call that person as being powerful ataupun having more power. In this case, whatever object or system that does the most work at lower time, that system or that object is having more power. Simple as that. Okay, so the work done of lesser time means that the object is of higher power. So kalau kita talk about the power and watt here, let's say kita talk about electrical appliances. Alright, so what ni? Let's just try to find an image search here. So as you can see here, I'm going to open it here so it's bigger. So as you can see, this is wattage chart. Maksudnya the power in the form of watt, which is the watt is the unit. So kalau you nampak kat sini, kita compare objects that are in motion. So object that are in motion, we're going to be considering handrail dengan electric fan. So kita boleh agak dah, electric fan consume less power compared to handrail ataupun for example chainsaw. Okay, so the reason being is actually because dia perlukan more electric power in order to change from electrical power to mechanical power. So electric fan ni walaupun dia berpusing sekarang, what happens is actually handrail is rotating at much more power. Okay, so maksudnya dia melakukan lebih banyak kerja dalam masa yang singkat berbanding kipas ni. Okay, so same goes to other appliances as well. Kita boleh compare. For example, we have slow cooker compared to microwave. So kalau kita heat food in the microwave, as you can see here, the watt is around 1000 watt. Tapi kalau kita masak nasi ke pakai cooker ni, it's of lesser watt. So the higher the power, the more that it is able to do work. So let's say kita cari microwave punya watt. So kita ambil, so this is an example lah, kalau low wattage ni dia dalam 500 watts. Tapi sebenarnya for microwave it's around 1000 watts sebenarnya. Okay, 1000 watt of microwave. So let's say kita letak jenama Samsung lah. So I don't know about this. I'm just clicking on nama ni link saja. So yang ni adalah 1000 watt. So the higher the wattage rating, the higher the power, or the lesser the time it took to heat up food. Okay, so that is about power. So power is W over T, the work over the time. Okay, ataupun kita boleh pakai force multiply with velocity. Macam mana kita dapat force multiply velocity? It is based from the equation of work itself. Sebab work ni adalah F multiply with the displacement kan. So the displacement divide by time, kita akan dapat velocity. So again, to obtain the second formula, the derivation is just simply expanding the equation to find the work. So the work ni adalah force multiply dengan displacement, and the displacement divided by the time as the denominator ni akan dapat velocity. Alright, so that is the unit of power. And in this question, we're going to do the question together. So number 6, a skier of mass 70 kilogram is pulled up a slope by a motor-driven cable. So this is the skier, 70 kilogram, and it is pulled up a slope by a motor-driven cable. So imagine this is the motor-driven cable attached to this skier. So question 6A, how much work is required to pull him a distance of 60 meter up a 30 degrees slope? Assume frictionless at a constant speed of 2 meter per second. Okay, so the question asks you to calculate the work done. Okay, so calculate the work done. In this case, remember the keyword here, it is of constant speed. The speed will be 2 meter per second. So the person here, the skier, will be traveling at a constant speed of 2 meter per second until the top of the slope. Okay, so the question asks you to calculate A, which is how much work is required. Work is equal to what value? So here we are being given the distance, which is 60 meter up this 30 degree slope. So we're going to be using this formula, W is equal to FD cos theta. All right, so cos theta definitely is going to be the angle between the force and the displacement. However, it is not going to be cos 30 degrees, because if you imagine this is the skier, the force that is going to pull this skier up is going to be the tension in the cable. Tension in the cable is the force that is doing work on this skier, and then the displacement is going to be 30 meter up the slope. So this is going to be the displacement. So the displacement and the tension will be of the same direction, meaning that it is going to be cos 0 degrees. Okay, so the work is going to be the tension multiply with the displacement d and then multiply with cos. Now we can say that cos theta is equal to cos 0 degrees because theta will be the angle between force and the displacement, angle between tension and the displacement. We use tension as the force that is doing work because, as you can see here, we want to know what will be the work required to pull this gear up a distance of 60 meter. Okay, so now we need to know what will be the force, the tension required in order to pull this gear up. Okay, so what happened is actually we have to do free body diagram in order to obtain the tension. So I'm going to further draw the weight, which is going to be straight downward. The weight of this gear is going to be mg, which is going to be 70 multiply with 9.81. So the weight is going to be equal to 686.7 Newton. So this is going to be the weight. Okay, so because we want to find the tension will be equivalent to the weight along the x-axis. Kat sini Wx, and then we're also going to have another component of the weight which is going to be Wy. So Wx ni kat sini akan jadi 60 degrees. Sebab dekat sini bawah ni akan jadi 30. Okay, 30 degrees. So definitely the top corner will have this angle of 60 degrees. So Wx is equal to mg or 686.7 and then cos 60 degrees. Okay, so we can calculate this multiply with 60 degrees is going to be equal to, okay, the tension, which is going to be 343.35 Newton. Okay, and then we know that tension is going to be equal to the weight because total force is going to be equal to 0. Kenapa total force 0? Sebab it is moving at constant speed. Constant speed meaning that there will be no acceleration. So it will be tension minus with Wx because we are considering the force along this slope. You can imagine total force Fx is equal to 0. Okay, so in the end, T is equal to Wx, which is going to be equal to 343.35 Newton. Okay, kita nak dapatkan tension sebab tension ni lah yang melakukan kerja untuk menyesarkan skier ni, I don't know in Malay, this skier up this slope having a displacement of 60 meter. Okay, so now we are ready to calculate everything because we have all of the parameter. So tension will be 343.35 and then multiply with displacement 60 and then cos 0 degrees is equal to 1. So the work done is going to be equal to 20,601 and then the unit is going to be in joule. All right, so this is going to be the answer. So let's check with the answer provided inside of the tutorial question number 6 for topic 5. Okay, so correct, it is going to be around 20.6 kilojoule. So that is our answer. Okay, so you can leave the answer as it is because it is correct. Okay, so now we can actually proceed to the next question, which is question 6b. A motor of what power is required to perform this task? Okay, so for question B, we need to calculate what will be the power in order to perform this task, which is pulling the skier up this 60-meter slope. So if you recall, for question B here, to calculate power, there are two equations, which is P is equal to W over T, or you can calculate the power using the force multiplied with the velocity. Because we have the velocity or the speed here is given 2 meters per second, and then we also have the force, which is the tension. This is the one that is doing the work. So we can use the second formula where the force is going to be 343.35 multiplied with the speed, which is going to be 2. So the power is equal to, okay, dia akan dapat jawapan dia 686.7. The unit akan jadi in watt.